Okay, so now here we are, we're chapter 7, and we're going to do section 7.1.1, and that's IP version 4. We're going to get started on that addressing. We already went through what the outline's about, so section 7.1 is going to cover a variety of things. So you should be able to do these things: convert between binary and decimal numbering system. We're going to work on that today. Describe the structure. That'll be the next video. Compare, okay, where we talk about unicast, broadcast, multicast. That'll be a separate video, and then we'll finish up public, private, and reserved IP addressing. And then that'll finish up section 7.1 before we go to section 7.2. So let's take a look at binary and decimal conversion. Okay, so decimal we talked about a little bit in class, but we talked about base 10. Binary, base 2. Base 10 means we use 10 digits to represent some. Binary means we're going to use 2 digits to represent things. So the digits here, we go 0 through 9. See, that would give us 10 digits, base 10, and then the groups increase by groups of 10. Okay, base 2. Now we're going to be using the digits 0 and 1, 2 digits for base 2. Alright, so let's take slides that talk about this. Here we have IP addressing expressed in binary. So here's an IP address in binary, okay, right here, and then we have an interface and an interface on a router. And remember, a router splits networks, so we have a network over here and a network over here. 2 different networks that we'll learn about. And then here is the addressing for the port on this router right here, and we're talking about IP addressing, we're not talking about MAC addresses here. And here's the IP address for right here. Okay, and then we have an address for this device on the network and an address for this device on the network. Now later on you'll learn these addresses are on 2 different networks. Now it's really hard to visualize this using ones and zeros all the time. So it is to look at an IP address. This is a little easier for us humans to see. Okay, so we have this address, and you can see we got a 10 there and a 10 there. We'll talk more about that later. Here we have 11 here, 11 here. These are on the same network, and this one's on a different network. In fact, this looks like that'd be a public address, so that's probably out on the internet somewheres. Okay, and so we'll talk about simplistically, how a network like this will work. In order to understand that, we need to understand the addressing, or at least get a start on it. See how we can do that. Dotted decimal addresses, for example, 132, 168, 10, and 10. These are the binary equivalents. So inside the router and computer and so forth, it sees the ones and zeros. Us humans look at this so that we can better visualize that. Divided into octets, groups of 8. Octal, groups of 8. So we got 8 bits, 8 bits, 8 bits, 8 bits that represent these decimal numbers. Dotted decimal address. 32-bit address, that would be this right here. This is the dotted decimal, but really these numbers represent these bits, and the bits, this is what the devices really look at. So to understand that, I called it what base. This is the decimal position notation, the radix. So these are groups 10, okay? And then here's how we indicate that. 10 to the 0, so this is ones. 10 to the first, tens, hundreds, thousands. See how that goes up based on that. What position? Position 0, 1, 2, 3, and that's where those powers come from. Okay, a little explanation here. So, system, we can figure out a number based on that. Okay, we have one group of 1,000, two groups of 100, 30 groups of 10, and 4 groups of ones, 1,234. Now, the only reason we do this is sort of a review. Hopefully it's a review from math that you had way back. You know, somewhere in elementary school, somewhere somebody talked about this in a math class. Or a lot, I remember that. So now, what we're going to do next is talk about the binary position notation. Okay, so now, this is base 2. So we're using 2 digits for each one of these. Okay, so it's base 2, so everything goes up by these groups of 2. 2 to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. So these now are the positional values. Okay? 16, 32, 2 to the 5th, 2 to the 6th, 64, 2 to the 7th, 128. Typically we like to work with these in groups of 8. You know, that would represent a byte. And so much of our addressing works in groups of 8 too. You also later on will learn about hexadecimal, which is base 16. And all these would be 16s instead of 2s. And we'll talk a little more about that later. The key here is understanding binary and then being able to convert to decimal. Okay? Base 2, therefore the radix is 2. Whereas in base 10 it was 10. So if we want to apply this, okay, so we have 1, 1, and then all the rest are zeros. So we have one group of 128, and we have one group of 64. If we add them together, we get 192. So this, if we were writing like an address, we would see 192 dot and then maybe whatever else is that we're looking at. But this is what the computer or the okay, so I'm going to pick up where I left off. I had a little glitch there. So anyway, the ones and zeros here represent, this is what we would look at in decimal form, and this is what it looks like in binary form. Okay? So then here, binary to decimal conversion, okay, this first one right here, we got 192. Okay? You divide it into 8-bit octets and apply the binary position value to the first octet number and calculate accordingly. And you just repeat it on each one. Okay, this becomes fairly straightforward as you move through the course. Again, binary to decimal conversion. So here's the second group. So you notice with this 1 is the 1 there, and then we have a 0, then we have a 1, a 0, a 1, and then 0, 0, 0. Okay, so we have one group of 128, no groups of 64, one group of 32, no groups of 16, one group of 8, and no other groups. And so that comes out to be 168. It's really just that simple. You will either have a place in your notes or somewheres where you'll have this written down where you can handily go back to it and use it, or what a lot of times I've always done is I just rewrite this group across the top. I just write that, I have that memorized, you know, 2 to the 0 is 1, 2 squared is 2, so you have that all figured out, and so then you can just go ahead and fill in your ones and zeros. And you could use the calculator to add them up if you wanted to. Okay, so this one 0, 0, 0, 0. So we have 0, 0, 0, 0. Then we have a 1, one group of 8, 0 groups of 4, one group of 2, and one group of 1. Just add them up, and you get 11. And then here's the last one. Same process. Get all those zeros, and then 1, 0, 1, 0 at the end. 1, 0, 1, 0. We got an 8 and a 2, so we have 10. Binary to decimal conversion. Now, the other way, it's working in reverse. So if you have a number that you want to convert, what you'll do, you got the binary position values, you'll look and see, can I take 128 out of the number? You know, whatever number you have. Can you take 128 out of that? For example, if the number was 192, you would say yes. You take 128 away from that and didn't calculate the difference. And then you see if you can take a 64 out of that. And so the process, okay, now can you take a 64 out of it? If you can take a 64 out of it, you subtract that off. There's the subtraction. And then can we take a 32 out? If you have a 32 left, yes. If you don't, well then that would be 0. If you have a 32, then that would be a 1. Okay? And you can just keep working. Okay, so here's the example. Our first thing is 192. Okay, that's greater than or equal to 128. So we take a 1 out, so now we have a 1. We subtract, and now we have 64 left. Now we're going to see if we're going to take a 64. Okay, we can take a 64 out, we subtract, and we have 0. So we have 1, 1, and all the rest of these will be zeros because we have nothing left. Okay? Again, this too might seem a little complex at first, but when you have your chart and you just work your way through and subtract them, and you can go 192 minus 128. Now you have a 64, so we take a 1 out of 1 there for the 64. We already took this one for the 192. 64 is 0. Then you know you're done, and all the rest of them are zeros. I don't have that video right here. You're actually watching a video. So 192 comes out to be this. Okay? So that is this place. That fills that 192 right there. These are the ones and zeros. Later on you say, well, why do we need to know the ones and zeros? There's some rhyme or reason to this later on. And that'll be covered in the next chapter, chapter 8, when we subnet, when we divide these up. Okay? And so our next unit would be the address structure. So we're done with this video right here.